This conference will now.
Sorry, just thank you all for being here this morning and looking forward to Dunling's presentation on seeding rate and calculation. We started these meetings last year, probably not at the best time of year in the summer, but we decided that, for those who did attend, they really seem to be getting a lot out of them, and it was a great opportunity to talk with each other and to ask questions of Dunling about this topic or any other agronomic topics that you have that or issues that you have that you may want to kind of problem solve with Dunling. That's what these meetings are for. And we've decided to do them 6 times a year. So we have a program this year too, which is available on our website. So without any more from me for sure this time, I am going to pass it over to Dunling. And thank you so much in advance for your presentation.
Good morning, everybody. Well, this is basically a farmers forum. I create this thing for, create opportunity for farmers to talk to each other. And I use this kind of short slideshow to open up the discussion. For those you don't know me, and my name is Dunling Wang. I am the provincial specialist alternative cropping systems, and my role is to support organic sector in the province and basically the technical support. So if you have any kind of questions regarding to organic agronomy or other kind of issues related to agriculture production, give me a call. And I may not know the answer, but I will find people who know the answers for you. And I will try to do my best to help you. And today's open seminar presentation, I call it seeding rate and calculation. Let's start. First of all, I would introduce, well, I guess everybody know that plant density. Plant density is defined to be the number of individual plants per unit area on ground, such as per square feet or per square meter. Plant density increases as the seeding rate increases, but decrease with the seed emergence. If the seed emergence decrease, then the seeding rate, plant density. And inadequate plant density is a common yield retardant, while right plant density is a critical for optimum economic returns. In general, the relationship between the plant density and the crop yield follow a quadratic curves. That means as plant density increase, at beginning the crop yield increase and reach to a maximum, at which point further increase of plant density will result in a reduced yield. And if you put more seeds after that point, and actually your yield will reduce more, as shown in the graph on the left. So what was the reason when the plant density is too low? And in that kind of scenario, each individual plant may perform at its maximum capacity, but there are not enough plants to reach the optimum yield. Therefore, total yield of the crop become limiting factor. Total number, the crop yield, the total number of the crop become a limiting factor. Also, when there's not enough plants numbers and you have too much space left between the plants, weed growth is promoted, which could increase the weeding costs. But on the other hand, if the crop density is too high, plants may compete against each other, known as the intraspecific competition, under those conditions, the performance of an individual plant become a limiting factor for maximum crop yield. It needs to be keep in mind that the density that provide your highest yield and the density that provide the highest revenue may be different. So you should shoot the both optimum yield and revenue when you try to balance your plant density. I want you to look at the graph again. Based on this kind of map, from point 2 to point 3, I mean seeding point, and your plant density increased by 50%, from 1,000 to close to 1,500 plants per square meter. But the yield difference from point 2 to point 3 is not much. Does this yield increase worth the additional seeds from point 2 to point 3, which basically increase the seeding rate by 50% to obtain that little yield difference? So if not, you may not choose. You may not choose to seed at a rate at point 3 because it costs a lot of seeds, or you may choose to use point 2, 1,000 plant per square meter, and that didn't give you the highest yield, but it looks like it made more economic sense. So somewhere between point 2 and point 3 is the best plant density. Even the crop yield is not the maximum. In practical sense, you may need to do on-farm experiment to find out the best seeding rate that fit your farm situations. Factors that are affecting seeding rate. In fact, seeding rate in organic cropping system is way more complicated than in conventional cropping systems. Seeding rate has been used as an organic management tool to deal with a lot of things, such as the weed pressure and soil fertility issues. In general, seeding rate is often increased as weed pressure is increased when broadcast seeding method is used, or sowing the seed too deep, or delay in seeding date, and reduce the row spacing. When seed is old, if you are using old seed, that means the germination and emergence rate is low. The seed is not well, or your seed is not well clean. I mean, with a high dockage, you will also need to increase the seeding rate. On the other side, if you are growing a very competitive crop, seed your crop early, use drill instead of broadcast, and you may reduce the seeding rate. If you grow a cereal crop, the cultivar that grows quick and tall with capacity of tillering, you can also reduce the seeding rate. In general, growing a monocrop often uses less seeds than an intercropping. Similarly, if you grow a cover crop or grow a cover crop mixture, and you can put in more seeds in comparison to growing a cash crop. When your soil fertility is high, meaning that you have a good soil nutrient supply, you can sow less seeds. And now, let's see how seeds rate was calculated. I use a flax as an example to demonstrate how we calculate seeds rate. Recent research by Dr. Steve Shirtlift at the University of Saskatchewan found that high seeding rate would help overcome the pressure of and getting a better crop yield. And his number is pretty amazing, like going up to 2,500 seed plants per square meter. We will need to convert. Why we want to do this? In some cases, the research results are expressed as a plant density, and we didn't. I didn't say that. We use a seeding rate pounds per acre. Because some of the research results are expressed as a plant density per square meter, rather than use a seeding rate of pounds per acre. So we will need to convert this kind of plant per square meter into pounds per acre. So that's what I'm trying to, try to demonstrate here. I'm sure that many of you are very familiar with the seeding rate calculation. In case you forgot how to do that, I just want to go through the quick review of this calculation process. And here's the example. To achieve a flax stand of 900 plants per square meter, which is equivalent to 84 plants per square feet. And what is the seeding rate? Given that the flax seeds that you have the following parameters: 1,000 kernel weight is 6 grams, and emergence rate is 60%. That means when you put 100 seeds into the ground, there will be 60 plants coming out. So the calculation, step 1, is to figure out how many grams of seeds is required for an acre. So 900 plants per square meter times the total square meter in an acre, that is 4,046.85, and it is equal to 21,853 grams. That's all the weight you need for seed an acre of land. Step 2, convert this acre into convert these grams into pounds by dividing 454 grams, and you got 48 pounds per acre. And step 3, justifying the emergence rate. That means remove those non-viable seeds. Use this 48 pounds divided by 60%, and which means you need to put 80 pounds of seeds to reach that 48 pounds, which you would be able to generate 100% emergence. Roughly, this 80 pounds is equal to 1.4 bushels per acre, about 56, because 1 bushel is about 56 pounds. And the ministry had a seeding rate formula that in almost every publication, which is a very simple way to do. Seeding rate in kilometers per hectare, which is different from pounds per acre, is equal to the targeted plant density per square meter times the TKW, the 1,000 kernels weight in grams, and divide by the percentage of field emergence. In other words, the seeding survival rate. And you will not use the percentage, but the whole number. If its emergence rate is 60%, you use the whole number, 60. And when we put those numbers, we did in previous slides, we have the same kind of results, 80 pounds per acre. Now, I was asked if I seed 5 pounds of flax with the seeds of TKW of 5.5 grams, The question was how many seeds I have put down in per square feet. And the second question, how many plants I would have in that square feet. So to answer this question, and we basically reverse that kind of a calculation process. So first step, convert pounds to grams per acre. See 5.5 pounds per acre multiplied by 454, and then you got 2,497 grams per acre. That's the seeds you spray in that acre area. Step 2, use a TKW to calculate the seeds numbers per acre. Divide the 2,494 gram by the TKW 5.5 and then multiply by 1,000 to get the seeds per acre. And that number will be 499,400 seeds per acre. And step number 3, divide the square feet in an acre. That means so many plants are 499,400 seeds in 43,560 square feet. Square feet, and you get a number 11.5 seeds per square feet. This is the answer to the question number 1. You actually put in 11.5 seeds per square feet. Or you could divide by the number of square meter in an acre. Use 4,047 square meters instead of 43,560 square feet, and you got 123 seeds per meter. Oh, I'll go up a little bit. Step number 4, if seed survival rate is 60%, normally the flax seed survival rate is really low. Answer to your question number 2 will be 11.5 times 0.6. You basically could achieve 7 plants per square feet, which is equivalent to 74 plants per square meter. In order to achieve uniform plant density in field, what you need to do, calibration. You need to calibrate your seeder before each use, especially if your seeder has not been used for a long time, like stored there for the winter. And the crop seeds may vary from one batch to another, or from, if you buy seeds from different buyers, calibrate them again. If you change your row spacing, remember to recalibrate the seeder for targeted plant density here. Here is the example. If you change the row spacing from 10-inch to 8-inch, without calibration, it can cost an increase in seeding rate by 20 to 25%. In order to maintain a uniform plant, the planting depths should be keep consistent. Yeah, that's my short presentation. And here's my contact. If you need to contact me or discuss anything with me, please use email, phone calls, whatever. Yeah, let's open that to everybody.